As we move on in trigonometry, we're going to start looking at the trig ratios as functions, like the sine, the cosine, the tangent, and their reciprocals. They're all, we've called them trig functions before, and now we're going to really look at them as though they are functions, like treat them like functions. And we're going to start looking at the graphs and some of the behaviors. And so really as we move forward, we're going to look at the graphs. That's the real big thing coming up here, is the graphs of the trig functions. We're going to start with the sine and the cosine, and then in future sections we're going to look at the tangent, the cotangent, and the cosecant and secant, and look at different transformations of those graphs. Okay, so we plot the graph and then move them around and see what happens. Okay, so this first section here, we're going to look at graphs of sine and cosine. So let's just take a look at the sine function, the sine of an angle, and we'll look at some things, just kind of review some things that we already know about it, based upon our discussion of unit circles and special triangles and things like that. And then we'll get into plotting the graph of the sine as a function, and then we'll look at sort of flipping that and doing the same sort of thing with the cosine. All right, so let's start with the sine. We'll just focus in really on the sine for a little bit. The first thing that I want you to remember is that the sine of an angle is the opposite over the hypotenuse of a triangle, right? So just a couple things, maybe I'll put them up here on the side as just some reminders, right? So the sine of an angle, we'll call it theta, is the opposite over the hypotenuse, right? That was our basic definition, a long time ago. We also know that the input then, this input of theta is an angle. Okay, the input theta is an angle. It could be measured in degrees, but we're typically now going to work with radians, okay? So it could be in degrees or radians, but we're really going to focus in on the radians from here on out. The output is a ratio, and we know a ratio ends up just being a number, fraction or a decimal, or it could even be a whole number, I suppose. But it's a ratio. Okay, it represents the ratio of the opposite side to the hypotenuse of a triangle. Okay, and the output's usually unitless. It doesn't really have a unit on it. Okay. All right, so we have seen, usually we represent it with sine of theta, theta being the angle. But because we have this input-output idea, and we know that the sine function gives you a single value for every input, we can really use like a function notation you may have seen in an algebra class before, and that is the f of x notation, function notation. F of x equals the sine of x, or we've used theta before. Now we're just going to start using x as the input. That's what we usually use when we graph things, right? Or when we think about functions. So the x is the independent variable, that's the input. And then the f of x is the output, or the dependent variable. Sometimes we think of it as x and y ordered pairs. So you could also think of it as y equals the sine of x. Okay, so this is like the function notation, or the idea of an ordered pair x comma y. All right. A lot of times, I guess these are interchangeable. So a lot of times we'll actually stick with the y equals sine of x, but just know that those mean the same thing. In addition to those, we know some other really important things about all the trig functions, really, and that is that in the different quadrants, we know which trig functions are positive and negative. We know that in the first quadrant, all of the trig functions are positive, In the second quadrant, the sine and its reciprocal cosecant are positive. In the third quadrant, the tangent and its reciprocal the cotangent are positive. And in the fourth quadrant, the cosine and its reciprocal the secant are positive. Okay, so we know those, we know that information there about the sines, the SIGN sign of the trig functions, so that the sine SIN is positive in both the first and second quadrants, but negative in the third and fourth quadrants. We also have seen from the unit circle discussion before that the sine value, the SIN, sine of x, is always between -1 and 1. Right? We talked about that. It never gets bigger than 1 and it never gets smaller than -1. So the value of the sine is always between -1 and 1, always. It could be 1 or -1, but it can't go beyond those. And for that reason, we now have an idea of a domain and a range for these functions. Remember, domains, the domain is all of the values that you could plug into a function. Okay, it's all the x values essentially. And so for a sine function, because the inputs are angles, and angles can be represented really in, if you keep going around the circle, your inputs could be anything, from 0 to, really large numbers, because you can just keep going around the circle and inputting larger and larger values. You can also put negatives in if you go around the circle clockwise. And so the domain could be any number. Any number can be an angle that you plug in to a sine function. So the domain is all real numbers from -infinity to infinity. What that means then is when we plot the graph of a sine function, it's going to extend indefinitely from left to right. It's going to cover the entire x-axis. The range, remember, the range of a function are the outputs. It's all the values you could have for y. The range for the sine function is going to be this restriction right here. It's all the possible outputs. Well, we said the sine can never be greater than 1. It can never be less than -1. It's always got to be between those two. So the range is from -1 to 1. Okay. All right, so that should give us a good foundation for the sine. And there's two other things that I should mention, just as a reminder, the two special triangles, right? We had our 30, 60, 90 triangle. Of course, if we're dealing with radians, instead of having a 30, 60, 90, it would be a pi over 6, pi over 3, pi over 2 triangle. But either way, I'll just keep it in the form that you're probably used to, the 30, 60, 90. And the side measurements are 1, 2, and √3. Whoa, that's a really sloppy looking √3. And then, of course, we have our 45, 45, 90 triangle. With side lengths of 1, 1, and √2. Okay? Okay, so then that can help us in developing the graph of a sine function.